Good morning, everyone. I am Swapnil Arjun Jadhav from first year BTech Information Technology. Today, I will presenting on the topic multiplexing and demultiplexing, which is from third unit of our data communication course. I hope you find this presentation informative. Let's get started. Let me quickly walk you through what we will cover today. We will start with introduction and need of for multiplexing. Then look for the four major types FDM, TDM, WDM, and CDM, each in detail. After that, we will understand demultiplexing. Do a comparison of all techniques, look at the real world applications, and finally wrap up with advantages, disadvantages, and the conclusion. So, what exactly is multiplexing? In simple words, multiplexing is a technique where multiple signals are combined and sent simultaneously over a single communication channel. Now, let me make this easy with an analogy. Think of highway. The highway is one road, but it has multiple lanes. Many cars travels on same road at the same time without hitting each other. In the same way, multiplexing allows many signals to travel through one single channel simultaneously without interfering with each other. The devices that combines these signals is called a multiplexer or mux. The device that separates them back at the other end is called a demultiplexer or demux, and the shared path between them is called a channel. Now the obvious question is, why do we even need this? Imagine there are 100 users who want to communicate. Without multiplexing, you would need 100 separate physical cables, one of each pair. That is extremely expensive and completely impractical. Also, most communications links have a single bandwidth larger than a single signal needs. So, without multiplexing, that extra bandwidth is simply wasted. Multiplexing solves all of this. It allows many signals to share one channel, reducing the numbers of physical links needed, cutting infrastructure costs and making full use of available bandwidth. In short, multiplexing makes communication efficient, scalable, and affordable. Here are mainly four types of multiplexing techniques. First, FDM, which stands for frequency division multiplexing, used for analog signals. Second, TDM, time division multiplexing, used for digital signals. Third, WDM, wavelength division multiplexing, used in optical fiber communication. And fourth, CDM, division code multiplexing, used in wireless system like 3G and GPS. Each of these divides the channel in a different way. Let me explain each one in detail. Let's start with frequency division multiplexing FDM. In FDM, the total bandwidth of the channel is divided into smaller non-overlapping bands. Each signal is assigned its own unique frequency band. Here how it works. Each signal is first modulated onto a different carrier frequency. All these modulated signals are then sent simultaneously through the same channel. At the receiver side, filter separates each frequency band and then each signal is demodulated to recover original. One important concept is here guard bands. The small unusual gaps between the frequency band that prevent adjacent channel from the interfering with each other. Key things remember in FDM all signal travels at the same time but each of different frequency. Looking at this diagram, you can see total bandwidth is divided into slices. Channel 1 uses the first frequency range, channel 2 uses the next, and so on. Small guard bands separate each slice. Now, where do we see FDM in real life? The most common example is FM radio. When you tune your radio to 98.3 FM, you are selecting a specific frequency band. Every radio station broadcasts its own frequency, that is FDM. Other examples include cable TV, where each channel uses different frequency, traditional telephone lines, and even ADSL internet, where voice and data shares the same wire on different frequencies. Now let's look at the time division multiplexing TDM. While FDM divides frequency, TDM divides time. In TDM channels, time is divided into repeating units called frames. Each frame is further divided into time slots. Every input signal assigned a one time slot per frame. So signal 1 gets slot 1, signal 2 gets slot 2, and signal 3 gets slot 3. And this cycle keep repeating. Each signal gets to use the full bandwidth of the channel, but only for a short fixed duration its time slot. Think of it like a round robin turn system. Everyone gets fair turn one at a time. Key difference from FDM in TDM signals take turn using the channel. In FDM, they go simultaneously on different frequencies. TDM has two important variants. The first is synchronous TDM. Here time slots are pre-assigned to each channel fixed. Even if channel has no data to send, its slot is still reserved and goes empty. This leads bandwidth wastage. Example T1 telephone lines with 24 fixed channels. The second is statical TDM, also called a synchronous TDM. Here slots are assigned dynamically only to the channels that have actually data, no empty slots, so it is much more efficient. Example, the way of data packets travels over the internet. So statical TDM is much more smarter and efficient but slightly more complex to implement compared to synchronous TDM. Moving on to wavelength division multiplexing. WDM is essentially FDM applied to optical fiber. Instead of dividing frequency, it divides light wavelength or color of light. Here how it works. Each data stream is molded onto a different wavelength of light. Thinks it is a different color of light beam. A device called optical coupler combines all these wavelengths into a single fiber. A receiving end, an optical prism separates the wavelength back into individual signals. There are two main variants. CWDM coarse WDM uses fewer channels, cheaper to deploy. DWDM dense WDM carry 80 more channels on one fiber. Used in long distance internet backbones. Real life examples are undersea fiber optic cables that connect continents using WDM. Companies like Geo and BSNL use WDM in their fiber network. Fourth type is code division multiplexing CDM. CDM is a unique. In CDM all signals are transmitted at the same time and on same frequency. What separates them is unique code assigned to each signal. Here how it works. Each sender is given a unique sequence of bits called a chip code. The signal is multiplied by chip code. A process is called spreading. All coded signals are mixed together and transmitted. At the receiver, the signal is multiplied by same chip code to extract the original data like a key, unlocking the specific signal. CDM is highly secure. Without correct code, the signal cannot be decoded. It is also very resistive to interference, real world use. 3G mobile networks use CDMA technology. GPS satellites, all satellite broadcast on the same frequency but each has unique chip code so your phone can distinguish between them. Now let's understand demultiplexing. Demultiplexing is simply reverse of the multiplexing. The demux receives single combined signal from the channel and separate it back into original individual signals, routing each one of its correct destination. Looking at the diagram, signal go into the mux, travel through the one channel and come out from the demux as separate signal against. The way demux separates signals depends on the technique used. For FDM, it uses band pass filter for each frequency. For TDM, it uses timing circuit that read each time slot. For WDM, it uses optical prisms to split wavelengths. For CDM, it uses correlator with the matching chip's code. One critical requirement, especially in TDM, the mux and demux must be perfectly synchronized so that right signals land at the right destination. Here is a quick side-by-side comparison of all four techniques. FDM works on analog signals divided by frequency used in radio and cable TV. TDM works on digital signal divided by time slots used in telephone networks, while WDM works on light divided by wavelengths used in fiber optic internet backbones. CDM works on digital signals separated by unique codes used in 3G and GPS. Each technique is suited for different medium and use case, which is why all four are still actively used today in different parts of our communication infrastructure. Let's now connect all this to the real life. Every time you listen FM radio station, that is FDM. Every time you watch cable TV, that is FDM. Every time you make mobile calls on 3G, that is CDM. Every time you check your GPS location, that is CDM. Every time data travels through the fiber cables, that is WDM. And telephone networks like T1 lines used TDM. So multiplexing is just not a textbook concept, it literally powering every from communication we use daily. Looking at advantages and disadvantages. On the advantages side, multiplexing is highly cost efficient as it reduces physical link needed, it ensures maximum bandwidth utilization, it is scalable, easy to add more users, CDM provides security through unique codes, and it is enabled the modern communication, internet, broadcasting and mobile. On the disadvantages side, it adds complexity in terms of hardware and synchronization. There are crosstalks in FDM guard bands and are insufficient synchronous TDM waste bandwidth due to empty slots, and WDM is expensive, and if shared connection fails, all signals are disrupted at once. Summarize, multiplexing is a fundamental technique that allows multiple signals to share a single communication channel efficiently. FDM divides by frequency, TDM divides by time, WDM divides by light wavelength, and CDM divides by unique code. Demultiplexing is a reverse separating and combined signal at the destination. Without multiplexing, internet, mobile network, GPS, and cable TVs as we know them simply would not exist. Thank you for your pay attention. I am happy to take any questions. Now I will explain two important questions related to multiplexing. First question, a cable TV provider want to transmit 100 TV channels through a single cable. Which multiplexing technique is used? The answer is frequency division multiplexing, or FDM. In FDM, total bandwidth is divided into different frequency bands, and each TV channel gets its own frequency. Because of this, many channels can be transmitted simultaneously through the same cable without interference. Cable TV and FM radio are common examples of FDM. Now the second question. Four users share one communication channels using TDM. If each frame has four time slots, explain the transmission. The answer is time division multiplexing, or TDM. In TDM, user shares the same channel by taking turns. The time is divided into frames and slots. After the frame is completed, the process repeats again. So FDM shares channel using different frequencies, while TDM shares channel using different time slots. Thank you for watching this video.